This is Wakana. She's 3 years old, and she's playing with Duplo blocks for the first time. She's not making anything fancy, but you can already see that she kind of gets it. This is an industrial robot. It can also put things together piece by piece, but only because a human told it exactly how. Put a pile of parts in front of the robot and say, make a car, and nothing much is going to happen. We humans have big dreams for our robots. We want them to look like us, move like us, and most importantly, think like us. But we keep hitting a wall. Robots are basically just computers, and in some pretty key ways, computers are dumber than 3-year-olds. So, how do we get to a robot that can start to think for itself?
That was kind of fun to watch this. It could actually jam the cap in there. It would probably be interesting to watch.
Is it really strong enough for that?
Yeah, well, it'll like completely destroy the cap in the process, but it'll get it in position. If you were trying to get a cap in a bottle for 10 minutes, you'd get pretty frustrated too.
This is Brett.
Berkeley robot for the elimination of tedious tasks.
Brett is a robot that can think.
The project we're looking at is seeing if Brett can learn through its own trial and error. This type of learning is called reinforcement learning. You get rewarded if you do well. You get maybe penalized if you don't do so well. And over time, you try to figure out how to do better. And we're trying to get Brett to learn the same way.
Initially, the robot starts out with very little prior knowledge. For example, it doesn't actually know which of its motors control which joints. First, it'll do it in a very clumsy way, just sort of fumbling around trying to get things in roughly the right arrangement.
It's learning.
And as it practices more and more, as it refines its strategy, the behavior becomes more precise. You can think of this as a little bit like the game of hot or cold. It gets, sometimes it gets a little bit closer to the goal, sometimes it's a little bit further away. You know, essentially by attempting the task and sometimes doing better and sometimes doing worse, it can figure out what kinds of behaviors lead to success more often.
Most robots are controlled by a string of code, so they execute the same motion over and over, without ever really changing or adapting. Brett's different. Instead of a series of commands, Brett kind of has a brain.
The robot is controlled by a large neural network.
Neural networks are a big deal in artificial intelligence right now. So we decided to go talk to this guy, Yoshua Bengio. He's one of the leading minds in artificial intelligence, and he actually helped create some of the first neural networks back in the 80s.
One way to understand what neural networks do is to consider the analogy with what's going on in the brain. What happens in brains is that the neurons receive signals that they send to other neurons. As you move forward in this chain, the brain is actually doing computation to understand the world around us. And neural networks imitate this process.
A neural network is an algorithm made up of the computer equivalent of neurons. Not physical, but virtual. The network takes on a problem, say trying to get this plane's landing gear into that little hole. Doesn't go so great at first. So, and this is the key, the neural network basically rewrites itself, connecting different patterns of neurons to get to the best solution. Give it another try, and there it is. The network learned and adapted all on its own. No human intervention necessary. Oh, and by the way, neural networks are blowing up right now. Robotics is kind of the least of it. Neural nets are at the heart of, just for starters, Google Image Search, Google Translate, Skype Translator, facial recognition on Facebook, recommendations on Facebook, handwriting recognition on checks, algorithms that can discover new medicines and detect lung cancer, most voice recognition software, Microsoft's Cortana, this algorithm that can play video games. Oh, and this craziness, which you might have seen, a project called Deep Dream from the folks at Google Brain.
After the Google Brain team had built these image recognition models. They then use these models to generate synthetic images.
This is Bloomberg's neural networks guy, Gideon Mann.
And so these were pictures that they colloquially were saying that the neural net dreamed. It's not clear that the artificial intelligence will be the same as the human intelligence, and it will probably be a whole lot weirder than we expect.
So, do you think neural networks are eventually going to be like the equivalent of a human brain?
It's hard to say how AI will be in decades from now. Really hard even for the best scientists that work in AI.
Worrying about the singularity and robots being self-aware and everything is like worrying about overpopulation on Mars.
We're still so far away from building something that's really intelligent, even though, of course, a lot of progress has been made.
I think the jury's still out on kind of the nature of what an artificial intelligence is going to look like. Is it going to look like a human brain and a human intelligence? Is it going to look like something very different? You know, even somewhat sacrilegiously, will it be more evolved than us? Will it be more ethical and moral than us? Perhaps.
Brett's artificial brain still has a long way to go, even before it catches up to Wakana. But that's not necessarily going to keep it from taking over the world, in a friendly sort of way. Robots like Brett that can figure stuff out for themselves can escape those monotonous factory jobs and find work in less predictable environments. In the near future, or the near-ish future, that could mean a lot more robots helping us out in our homes, offices, hospitals, and nursing homes. Beyond that, who knows? Maybe someday we'll have a robot that's even smarter than a 3-year-old.
It is always fun to see what it comes up with.